the 3 unit vectors at pi equals 4, or pi over 4, excuse me. So first, I would say what I did was I just found the equations for each of the following. Well, obviously r is already given to us by the problem. R of t equals cosine t I plus sine tj. And in order to find t, we just have to take the derivative of the position, which is a velocity, and divide it by the magnitude of velocity to get negative sine I plus cosine tj. I'm gonna zoom in a little bit smaller for y'all. Okay, so if you substitute, you can get negative 1 over root 2 I plus 1 over root 2 j, I believe that says. Also, for n, you just have to take the derivative of the t vector and divide it by the magnitude of the t vector, in which case you are just solving for taking the derivative and solving for the magnitude and dividing it by that to get negative cosine t of I plus negative sine t of j, and substituting pi over 4, you get this value. And b is probably the most complicated one. You just take the cross product of t and n in that order, and you have to set up to the matrix. Just don't make sure you remember like the subdeterminant or submatrices, and just solve. You realize that this is 0, and because this 2 the column's filled with 0. This is also because the column's filled with 0. And this just ends up being 1 because sine squared plus cosine squared. So you get b is equal to k. Okay, so now comes like the trickier part of the question. So you know that the osculating curve, or b, is normal to the osculating curve. So we use the vector equation for b that we found, which is b equals k. So I equals 0. We're using, by the way, we're using the equation for the plane less than 12.6. So we're just substituting the values in and solving and isolating the variables on each side to get z equals -1. Same thing with the rectifying curve. You're just n is a normal vector to the rectifying curve, so you're just substituting the values in and isolating and solving to get x plus y equals root 2. It's a normal vector, lastly, which is orthogonal to t. You again just substituting the values in, and the negatives cancel, so you get x plus y equals 0. And yeah, that's problem number 7.